Hi everyone, it's Arthur from Leg Education again, and in this last video we are going to talk about animation and how I exported it to the real robot. But just to recap, first video we were talking about prototyping, how to build and try different things. In the second one we were showing the different tricks about also the legs, that there is no motors here, but it follows. So you can create some mechanisms that will add life to your model, but they just following another mechanism. This third one, we talked about how to create your model in Studio. In this last one, we are going to use another software. Its name is Blender. I used to use other softwares, but all the other ones, they are you need to buy a license. And the cool thing about Blender, it's a quite interesting and really good software. So you can do a lot of things with that. It's most of the people that use for special effects or 3D animation or 3D visualization. So you can do a lot with that. What we are doing, we are creating a rig. What is a rig? You have the character and you need to create controllers on this so you can animate. So we just have the Studio just give us the mesh, like the objects in a 3D environment. Now with with Blender, we are connecting all the different elements and saying, okay, when you are moving this part is connected to a motor. We are going to we have controllers to help you, so you don't need to move every part, just having one controller. Let me show you how it works. So here I have like the model, and right now it's already set up. So we have everything here. And let's see if I need to. Yeah, so here we have our model. So we have Elles, the 3D version of it. And if you pay attention, you're going to see that we have different elements that we don't have in the real one. So the first one, like this green element, big one, is one bone. So, and we have several bones, they are inside. So we have another one here. So as the real bones, they are the structure that you have to control your robot. So they will create relation between things. Remember that I built this leg in a straight angle. I will show why, because when I was building it, let me just grab the bone up here. So I didn't place the bones like that. It was in something like this. But as you can see, all the elements are following the bone. So when I move the leg, it will move in the right way. But what happens here, I have this bone attached to the rib. So when I rotate, it will follow it. And we are doing this for all the elements. So if I go up here, we have like the top. I'm not just moving the parts, I'm moving also and creating relations with them. I think it's going to be easier for you to see here. So here I have the shoulder mechanism. The shoulder mechanism works like this. I have this rack here and I have a lever. So when I'm moving it, it shoots. So like I have the motor here, I have a gear. So I need to go inverse kinematics. So if I'm moving here, what is going to be the position of the gear? So it's the inverse that I'm doing. The inverse kinematics is the same thing that happens with the leg. I don't know the position of the knee, the rotation of the knee, but it was able to calculate for me. Remember that I presented also the ears movement. Here it is now. So going up and down, going up and down here. So, and that's what I want. I want to animate the controllers, and it will give the position of the motors. Let me show another one that is quite complex. So here I have the two motors, and both of them I have like a ball link here. As you can see, I'm moving the neck. I'm not moving the motors, but the motors will react to the position. So both of them need to work together to move the head up and down. If I want to have like the turn, the dog turn, I need to use this controller. So that's what happens. So one motor needs to go up and the other one needs to go down. Okay. When I'm moving like the shoulder I have like gears here, and I also need to calculate them. So I'm moving it, so I need to calculate the ratio between the gears. So everything, it's around the relation between elements here. The cool thing about this kind of softwares is that we have a lot of animation tools. Let me just move to the timeline. And so you can see the keyframes here. And I already have an animation here. So let me just move like this. And I made this animation to, like, if Elles is late for something, so she will look at the watch. So moving, having a look, moving one side, looking to one side, realizing that it's quite late, putting the hands on the head. That's a simple animation. So, and I can use all these tools to create the animation. I could also create loops and other stuff. Let me open another animation that I have here. So I will not save this one. Dance. Let's see if dance 3 is the correct one. I'm not sure. Oh, it's downloading here. But so what happens is that I can create several animations. All these animations I will export. How? Remember, I have the data from each motor. I'm going to create one TXT file, a text file with all the coordinates for each motor. It's a long list. And with that list, I send to the hubs, and they are able to catch each one. I will start turning it on, so we it's a lot of hubs to turn it on. It's also a lot of hubs when you need to charge. Yeah, so, and to control Elles, I have a controller. So 2 hubs, and I have a list of animations that I already have here. So let's see if this one is looking for. Great. Now this one goes here. Yeah. Yeah, everything is fine. So let's come back here. It's open now. So here I have one animation. So, oh yeah, it was another dancing that I was doing. So like, let's play here. So as you can see, I'm trying to connect motors, the movement of the legs, the movement of the arms, trying to create like a wave thing. Okay. But let's see how it works. The first thing that we need to do when we are operating Elles, we need to wake up her. She's in a sleeping position now, and I will wake up her. So now she's in the rest position, and now I can move to the other ones. So Elles is able to look around. Hi, Elles. Because Elles is doing a lot of stuff these days, she needs to stretch a little bit. So let's stretch. Yeah, doing some exercise. Another cool thing is that you can interact with her, because I did that animation. So I will just place Alice like this, and let's do a high five. Hi Alice, how are you? Great. But I can say for you that the most awesome thing that Alice is able to do is to dance. Alice, can you give a good dance for us? Cool, right? Let me show you how these files look like here. So let me just open one of the files. Here is one of them. As you can see, it's a long list. Each line, I have the position of each motor. So one fit, the other one. Like this one is that shows up and down. These ones are related to the rotation of the body. So each one until the last one. This one is just information about in which frame I have. This file here, it's related to the stretching. So it has 420 frames, and each hub will read that file and go back here. That's how it looked like. So let me see if I have another one. I think I have another animation here. So it's waving, right? Right, Alice? So say hi to everybody. Cool. Well, Alice is still in work in progress. It looks quite good now, and I'm happy, and that's why I'm presenting to you. But I have several plans for the future of Alice. One of them is maybe changing the display to an eye, so I can have like an extra movement. So when we are looking around, sometimes our eyes goes first. So my eyes will go first, and the whole body will follow it. So that's another thing. I already have one program for that, but I didn't implement for the full file. Another thing is now with the Raspberry Pi integration, maybe we can use a camera. So having Alice, instead of just using the ultrasonic sensors, I could use the camera. So interacting with people, recognizing faces, and playing animation depending on the what is happening in front of her. So following a ball, I think it would be quite interesting and easy to make. But it's a work in progress, so probably I'm going to add new stuff in the future. And I hope it helps you to understand a little bit the process and also a little bit how it works. It's complex to explain every step, but if I need to divide it, is like that: building Alice, trying and prototyping it, creating the simple 3D file in Studio. The next one is when you're going to Maya or Blender or some kind of 3D softwares, and after exporting all this data. The cool thing is that the program that I have in the hubs here, they are really, really simple comparing to what maybe you're thinking. Remember that we use the file copying a position of one motor to another one. It's funny, but that's the kind I'm not using Scratch in that one, I'm using Python, but it's almost the same thing, but I am multiplying it for every motor. So instead of having a motor go to that position, I have a file, and the Python file just need to look that position and follow that. It makes it really fast, this cycle, and the result is what you saw. So thank you very much. I hope we have other opportunities to explain more or doing other projects in the future. So see you around. Bye.